Video is going to be talking about translations and how they work um, in geometry. So the first thing we kind of need to figure out is what is a translation. We kind of know this from the fact that in languages you can translate between different languages. It doesn't mean that the statement you said changes at all. So really, essentially, it's just taking the in when we're talking about languages, it's taking the words from one language and sliding them over to the other language. Um, and that's exactly what a transformation is. All of the points in the preimage are moved in the same direction with the same distance. So we slide whatever figure we're talking about from one spot to another spot. Let's look at an example of how this can be done. So we want to translate this triangle down 4 units and right 7 units. First off, let's talk about the notation. The notation involved in this is going to be the notation involved in this is going to be relatively simple. We have a capital T for translate, and then we have this. So right 7, when we move right, that's positive. Down 4, when we move down, that's negative. So I'm going to give myself a tiny bit more room there. Put -4. Okay. So what we're going to do is we're going to take every point, and I'm going to do this with a line, and we'll make the lines that color. With every single one of these, I'm going to start off by going down 4. 1, 2, let's see, that's 1, 2, 3, 4, and then to the right 7. 1, 2, 3, 4, 5, 6, 7. I'm going to do the same thing for this point, but notice when I go down 4, 1, 2, 3, 4, and then to the right 7, 1, 2, 3, 4, 5, 6, and 7. These two lines are the same distance apart. Let's do it for the last one. We go down 1, 2, 3, and 4, and then to the right 1, 2, 3, 4, 5, 6, and 7. Okay. So my triangle, which this program only inserts a equilateral triangle if I recall correctly, but my triangle is now here. And as we see, its shape is the same. Its orientation is the same. All we did was slide it from one spot to another. Let's look at one where we don't necessarily draw the lines, because you don't have to draw the lines. They just, if you want to, you're allowed to. Now, let's do this translation. What is the translation 5, 3 of the given triangle? Well, the translation 5, 3, 5 is telling me to go right 5. The 3 is telling me to go up 3, which if you look at this image isn't going to be something that we can do very easily. So I'm just going to change that to a negative for our purposes. I will fix it before I post these. And then we go down 3. Okay, so I go right 5, 1, 2, 3, 4, 5, down 3, 1, 2, 3. There's one of my points. 1, 2, 3, 4, 5 to the right. 1, 2, 3 down. And 1, 2, 3, 4, 5 to the right. 1, 2, 3 down. And we now have this shape. So our translations aren't that bad. We're just counting over and down, essentially. So we take our horizontal distance and our vertical distance into account, which is all these numbers represent. This 5 is the horizontal distance. And this, what I turned into a negative 3 so that we could actually do it, is our vertical. Our vertical, and I'm going to put in quotation marks on both of these, distance. So, a composition of rigid motion. Now, with a composition of rigid motion, we basically are doing more than one transformation. Here's the thing. We have to make sure we are doing the correct thing at the correct time. So let's take this composition here, which, by the way, that symbol just stands for composition. Now, what are we going to translate? Well, we are going to translate whatever this shape is. So our translation is going to be of this entire thing, which tells us that before we do our translation, we need to do our reflection. And in general, perform the rightmost transformation first. So let's actually do this exact transformation. And we have that here. So I'm going to perform this transformation listed here. I need to perform this first. So I need to reflect around the line x equals -1 first. Let's go ahead and figure out what A, B, and C are. A is 2, 0. B is 3, 3. And C is 4, -1. Okay. So let's talk about the reflection about the line x equals -1. This is going to affect our x values. And if you remember, a reflection means that this distance, which is 3, is going to line up with a distance here of 3. So our A prime is this point, which, by the way, is -4, 0. Okay. Our C, again, we have a distance of here with our C, a distance of 5, which means over here we need to go a distance of 5. 1, 2, 3, 4, 5. There's point C prime. And then B, we're going the distance of 4, which means we're going to do a distance of 4 over here, giving us B prime as that. So that triangle, give or take. We're going to go ahead and get the points labeled for these, and that would be A prime is the point, as we said, -4, 0. B prime is the point -5, comma 3. And then C prime is the point -6, -1. Okay. So this is our new set of points, so to speak. And what we're going to do is we're going to translate these points. So we are now performing the translation on those points. I'm going to erase some of the lines just for our ease of visuals. Okay. So what is my translation? Well, my translation is 2 right, 3 down. 2 right, comma, 3 down. So let's do it. A, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. This would be our image, which is going to be C double prime, A double prime, and B double prime, just to stay consistent with the notation that I've used here. So this transformation yields this shape here. Okay, that is all for this video. I hope you are remaining safe, and I will see you in the